Okay, this is just another example that we can look at for a polar equation of a conic. It says analyze the graph of the polar equation, r equals 32 over 3 plus 5 sine theta. So the first thing we talked about doing was taking this number 3 and kind of recognizing that that should be a 1. So for our general form, we have a 1 plus e sine theta on the bottom. Okay, and so I can't identify E until I have a 1 there. So right now I can't say that the eccentricity is 5 because I don't have 1 plus 5 sine theta. I have 3 plus 5 sine theta. So the first thing we're going to do is divide everything by 3. So divide the numerator and the denominator by 3. That's going to turn that 3 into a 1. But if I divide one part of this expression, I need to divide each part of the expression. So now I have this equation, r equals 32 thirds over 1 plus 5 thirds sine theta. So again, this is my 1 plus e sine theta. And so e is 5 thirds. Because e is 5 thirds and that's greater than 1, this graph is going to be a hyperbola. And I could do a rough sketch right now. I could say, I'm just going to make a really small one right here, that because of the plus sine theta, my directrix is going to be above the pole. And that comes from, like that observation comes from our very first thing we did with the definition. We started with a directrix to the right of the pole, and we derived the equation, and that equation had a plus e cosine theta. And we talked about how if it was minus e cosine theta, that means we would have been looking at a directrix to the left of the pole, and then we translated that. So what does that mean for plus sine theta versus minus sine theta? So the 1 plus e sine theta means my directrix is above the pole. Remember that the pole is the focus of the graph, and we're doing a hyperbola. And so I'm going to have some kind of hyperbola that looks like this. Remember, a hyperbola has another one that goes above it, and so I probably also have another directrix. Well, I do have another directrix and another focus. So that's kind of the idea of what that's going to look like. Now, the other thing we want to find out then, we have E. E is 5 thirds. We want to figure out where is the directrix. Okay. We call the major axis of the hyperbola a transverse axis. Okay, I'm just going to say major axis because that's what we've called it before, is on this line theta equals pi over 2. Now, if I want to draw a real graph, I want to figure out, because it doesn't tell me here, but I want to figure out, well, what is the p-value? So to graph, since we know where the pole is, we know where the focus is, we need to find the directrix location. And so if I have this 32 thirds plus 1 times 5 thirds sine theta, the 32 thirds is equal to E times P, because my equation that I'm working from is R equals EP over 1 plus E sine theta. And so EP has to equal 32 thirds, because those are both the numerator of the equations. So EP equals 32 thirds. And we said that E is 5 thirds. So 5 thirds times P is equal to 32 thirds. If I multiply both sides by 3/5, then P is equal to 32 fifths. 32 fifths is 6.2. So I can go to my graph and say my directrix is located at y equals 6.2. Once I have my directrix, I already know that there's a focus right here. I can plug in my quadrantal angles to get the vertices. So I'm going to have a vertex at something, comma, pi over 2, and something, comma, 3 pi over 2. So I can take my original equation and plug in pi over 2. R equals 32 over 3 plus 5 sine pi over 2. So 32 over 3 plus 5 times 1. So 32 over 8. So at pi over 2, my R value is 4. Now, since this is a hyperbola, I know that my graph is going to look something like this. And then there's going to be another vertex way above maybe not way above, but above where the directrix is. So if I plug in 3 pi over 2, I'll get that other vertex. When I plug in sine of 3 pi over 2, I'm going to get negative 1. So it's 32 over 3 minus 5. 32 over 3 minus 5 is 32 over negative 2, which is negative 16. So if I go to 3 pi over 2, which is down here, I have to go backwards negative 16 units, which doesn't even fit on my graph. It's going to be up by the word directrix somewhere. And then to figure out how wide my curve is, I just want some additional points, and that might be easiest to plug in 0 and pi. So 32 plus 3, 32 divided by 3 plus 5 times sine 0. Sine 0 is 0, 5 times 0 is 0. It's 32 divided by 3. And they're both going to be 32 divided by 3, which is a little bit beyond 10. And so that gives me the shape of the hyperbola. And you'll have another one way up there, but what I will probably only ask you for is what is the other vertex? Not necessarily can you find some other points on the other vertex. And so that's how you do this problem.